All right, scientific notation with positive and negative powers. Scientific notation is written as the product of a number between 1 and 10 and a power of 10. So when we're talking about a number between 1 and 10, this is the whole number here. In the first place. So this is your 1's place value. Everything to the right will just be any number of the decimal. Let's just review some powers of 10 real quick. If we start off with 10 to the first power, that's going to be 10. If we go 10 to the second power, or 10 squared, that's 100. If we do 10 cubed, that's going to be 1,000. 10 to the fourth power is going to be 10,000. And let's do one more. 10 to the fifth power is going to be 100,000. All right, so now let's go in the reverse direction. So 10 to the 0 power is a unique case. Anything to the 0 power is 1. Now let's talk about negatives. So 10 to the negative 1, that's going to be 1/10. 0.1 or 1/10. All right, if we do 10 to the negative 2, that's going to be 1/100. 10 to the negative 3 is 1/1000. 10 to the negative 4 1/1000, or sorry, 1 in 10,000. Okay, and we'll stop there. All right, so let's review scientific notation. All right, we got some steps here. We're going to place the decimal point between the first and second digits on the left of any number to make it 1 in 10. So let's say I have this number here, 93 million, and we want to write it in scientific notation. The first thing is to place the decimal point between the 9 and 3. Then we are going to count over how many places. So we have 1, 2, 3, 4, 5, 6, 7. 7 places to the right is going to make it to the 10 to the 7th power. So when we write this, we have 9.3 times 10 to the 7th power. So if you actually multiplied it out, you would get 93 million. All right, let's take a look at another one. So we have 6,400. So we are going to take the two digits on the left and we're going to write it as 6.4 times 10, and then we're going to count however many places it takes to go over to the right. 1, 2, 3. So 6.4 times 10 to the third. All right, look at example 4. The two digits to the left are 5 and 7. So we're going to write 5.7. And now we're going to count however many places it takes to the right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so 5.7 times 10 to the 11. All right, last one. A light year is the distance that light travels in a year and is equivalent. So write this distance in scientific notation. We are going to write 9.461 times 10, and we're going to count over to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So now we're going to do the opposite of it. This time it's going to be in scientific notation, and we're going to write it in standard notation. So we're going to find the powers of 10, count that number of places to the right, and add zeros as needed. Okay, so we have 3.5 times 10 to the 6. Well, if we write down 3.5 and we go over 6 places, you go 1, 2, 3, 4, 5, 6. You're just going to fill in the placeholders. All right, so we've added 5 zeros, and we now have 3,500,000. All right, let's do another one. So we have 7.034, and we're going to count over 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Could put some commas in here. Okay, let's try another one. We have 2.36 times 10 to the 5th. So we're going to go over 5 spaces. 1, 2, 3, 4, 5. All right. It says the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 and 10 to the 6 grams. Write this mass in scientific notation. So basically we're just going to add 6 zeros to this. So 1, 2, 3, 4, 5, 6. That one was easy. Okay, so this front side we did positive exponents, and they were all whole numbers. Now on the back side, we're going to talk about negative exponents. The negative exponents are going to be less than 0. So put the decimal to the right of the first non-zero digit. Count the number of places you moved the decimal point. This becomes the exponent on the power of 10. Since the original decimal value was less than 1, write a negative exponent. So example 1, we are going to write the number 3, and we are going to count the amount of spaces it takes to go to the right. We have to go 1, 2, 3, 4, 5, 6, 7, 8. So we're going to say 3 times 10 to the negative 8. Remember, you want to go behind the number. All right, so now let's try the next part. The number 8, we want to go between the number 8 and 2. So we're going to have 8.29, and we need to see how many places we need to go. So we're going to start at the decimal point. We're going to count 1, 2, 3, 4, 5. So 10 to the negative 5. All right, same thing here. We're going to go between the 3 and the 0. So we're going to have 3.02 times 10, and we got to count how many spaces we need to go. 1, 2, 3, 4, 5, 6, 7. So we have 3.02 times 10 to the negative 7. Typical blood cell in a human body has a diameter of approximately 0.000007 meters. Write this diameter in scientific notation. So we want to go behind the 7. So we're going to have 7. And we need to hop over 1, 2, 3, 4, 5, 6. So 7 times 10 to the negative 6. All right. Now we're going to write this in standard notation. This time the negative exponent's going to be given and we're going to write it out. So the first example says 2.33 times 10 to the negative 6. So you have 233. And you're going to hop it over 6 spaces to the left. So you're going to go 1, 2, 3, 4, 5, 6. And then you just add in zeros in that place. So 1 0, 2 0, 3 0, 4 zeros, 5 zeros. So it's going to be 5 zeros and the rest of the number. All right, same thing here. We're going to have 1 0, 4, 5. And since we're here, we want to go 6 hops to the left. So if we go 1, add a 0, that's 2, add another 0, 3, add another 0, 4, add another 0, 5, add another 0, 6. All right, we have added 5 zeros there. All right, next one. We have 9.9. I don't need the decimal anymore. Do that again. We have 99 and 10 to the negative 5. So we're going to go 5 spaces to the left. 1, add a 0, 2, add a 0, 3, add a 0, 4, add a 0, 5. We've added 4 zeros. Last one. Jeremy has measured the length of an ant as 1 times 10 to the negative 2. Write this length in standard notation. So if we go over 1, add a 0, it's just 1/100th. All right,